This is Austin Buckle, Sales Manager, DB Sales. Thank you very much for coming and attending the webinar for today. Today's webinar will be presented by Jason Gagan from US Draft. We are presenting boiler venting definitions, codes, and methods. I did want to let everyone know that if you do have any questions, feel free to use the questions and answer box, type those in. I'll be able to kind of coordinate with Jason as he's presenting to stop him and answer those questions as we proceed along. Of course, if you do have any questions at the end, feel free to chime in or again, text or type more questions in the questions and answer box. But with that, I will hand this over to Jason and get started. Thank you very much.
Cool. Thanks, Austin. Yes, welcome, and I appreciate the taking the time this morning. As he said, this is going to be a very kind of informal thing. So if you have a question, the Q&A button works great, and we can answer those along the way as well as at the end. So a little bit about who we are and what we do. RM Manifold is a draft control manufacturer out of Fort Worth, Texas. We go to market under 3 different brands. LF Systems focuses on commercial laundry exhaust, high-rise exhaust, and stairwell pressurization controls. KW USA is a partnership with a German manufacturer, Kutzner and Weber, for specialty products, fireplace fans, pizza oven fans. And then US Draft Co., which is the brand we're focused on today, focuses on draft controls for any gas-fired appliance, boilers, water heaters, pool heaters, unit heaters. And I'm going to use the term boiler very generically. Again, this applies to any gas-fired appliance. So if you deal with plumbing applications, dealing with domestic water, this will work as well with that. So a little bit of background about myself. I was born and raised in the boiler room. My father was a licensed plumber. After school, I decided I was way too smart for college, so I went straight into the industry, working in a warehouse, and learned early on that I didn't want to be dragging around 40-gallon water heaters and furnaces in the middle of January in Chicago, which is where I'm originally from. So I started getting into really diving into system designs and product knowledge. So kind of worked my way up to counter sales, inside sales, and some outside sales. So most of what I am going to express today is just learned through the 27 years I've been doing this. So, definitely this is mostly, or partially a conversation as much as it is a training. So the one thing I have learned over that period is venting causes about 90% of your boiler problems. If you have light off issues, if you have rumbling in the chamber, if you have sooting in your burners, in your heat exchangers, it's typically caused by venting. The other 10% is caused by gas pressure. So if I can solve 90% of your problems, it's going to be a pretty successful day. So again, a quick outline. We're going to talk about venting, just some general venting 101 stuff, common venting, our connector draft system, boiler room safety, and then we'll touch on the other brands at the end again. So when a boiler manufacturer decides to create a product, they have 2 different kind of lanes that they can go down. One being the ANSI categorized appliance, Z21, the other one being UL 795. So in general, rule of thumb is if it has a prepackaged burner built into the box that you're buying, it's most likely going to be a categorized appliance. If the burner is on the exterior, something that you can change different styles, fire tube type boilers or something like that, that is most likely going to be a UL 795 building heating appliance. Now, the reason I tell you that is that there are 2 different things you have to look for when it comes to the type of appliance you're venting. So looking at Z21 first, they were real creative when they named these. They call them categories 1, 2, 3, and 4. And I could read these verbatim if you'd like. It's very boring, put you to sleep. So instead, we're just going to look at the nice little cheat sheet that they give us. And there's basically 2 things that determine a venting's category. One is whether the outlet pressure is negative or positive. Negative pressure meaning something is pulling those flue products out, typically Mother Nature, or if the flue products are positive, something is pushing those flue products out, and that's typically some kind of an internal fan. Okay. The second factor is whether the outlet of the vent system is going to be condensing or non-condensing. Notice I said the vent system, not the boiler. There are plenty of boilers that are non-condensing style product. First one that comes to mind is a, Futura 2, or excuse me, Futura 3 from RBI. That is a non-condensing combustion chamber. It's made of materials that are not designed to handle condensate, but the flue temperature are just on the cusp to where once they hit the stack, there's a good chance that they will condense. So we typically say 85 to 86% thermal efficiency is that cutoff. If it's a non-condensing vent system, that's going to be on the upper half. If it's a condensing venting system, that'll be the lower half. Good news is there's only two types of materials to use. One is for category one, that's your standard UL 441 B vent. It's a double wall, half-inch air gap, either galvanized or gal aluminum inner and outer wall. Very restrictive on things you can do, but code tells you a whole bunch of things to follow in order to design a category one system. Categories 2, 3, and 4 all use UL 1738, whether it's either a polypropylene or a stainless alloy of some type. Code actually doesn't tell you what material to use. You just have to be able to meet certain restrictions in the code itself. So categories 2 and 4, you use this for the condensing aspect of the flue gases. Categories 3 and 4 have to deal with the positive pressure. So it has to be a pressure sealed material, and it also has to be able to withstand the corrosiveness of condensate. And there's a certain test that you have to pass in order to get that UL 1738 listing. One product I have not mentioned is PVC. PVC is not a UL listed product for venting. The way that they do get approved for venting is that it's approved by the burner, or excuse me, by the boiler manufacturer itself. So it's actually part of the packaged installation approval rather than the actual product itself. So in order to get that, though, they do not have to pass that 1738. So the problem with PVC is it has a very low melting point, about 155 at atmospheric pressure. And what happens is if you exceed that temperature, the molecular structure of the pipe starts to change to where it's no longer a PVC. It's just a very brittle plastic. And it has this kind of yellowish brown tinge to it. Everyone says, oh, it burnt the plastic. Basically, yeah, the molecules started moving around and heated up. So it starts to get that hue to it. You walk over, tap it with your knuckle, and it'll crack. So many engineers respond saying that, yeah, that's why we only allow CPVC. And yes, CPVC is a higher temperature. It's about 190 at atmosphere. But in order for a boiler to be installed with this product, with a non-listed product, they have to have some type of limiting device in their boiler that if the boiler flue temperatures start to exceed what those limits are, it'll actually either shut down or detune the boiler. And typically this is going to happen in colder climate months when you need the boiler the most. Those flue temperatures start to increase, and then it'll start to detune the boiler. So we always recommend using a UL listed product for your venting system. So much so that the largest pipe manufacturer in the world agrees with us and says, don't use our pipe for that application. There's again, discussions back and forth, and this started in the furnace industry and has kind of made its way into condensing water heaters and is now slowly crept into the heating boiler systems. And it really all has to do with your return water temperatures. If you're doing, a very low temperature system, you could probably get away with it and be just fine. But you may design a system to run at 80-degree return, and then the building does a slight remodel and they decide they need 120-degree return or 140-degree return, and now that vent system becomes a problem. So we always recommend using UL listed materials. As far as 795, basically this is anything that's in order to get categorized, you cannot exceed half a pound of gas pressure inlet. You cannot exceed 12.5 million BTU input, and you cannot exceed 15 PSI of steam. So most of your fire tube, vertical tubeless, water tube type products, vent tube type products are going to be a 7095 building heating appliance. And the reason why that matters is because their flue temperatures can accelerate dramatically higher than what the 1738 pipe can handle. So they make a special UL 103 pressure pipe. It's usually made out of either 304 or 316. Again, aluminized or stainless steel outer. This is pressure tested up to 60 inches. Please do not put that in your boiler specifications. It will blow out the seams. That 60 inches has to do with generator exhaust. So a solid pipe can handle that. In boilers, we are allowed to use adjustables, and those adjustables are not rated for 60 inches. So please don't do that. And then there's typically anywhere from a 1 inch air gap all the way up to a 4 inch fiber insulation, depending on the type of boiler, the steam pressure that you're running, that type of thing. So good news is that Austin and his team can help you select that with the appliances. When it comes to sizing gas vent, there's two things that we look at. There's NFPA and the ASHRAE handbook. NFPA basically tells us what we can and can't do, and then ASHRAE tells us how to do it. So we typically will start with the ASHRAE chimney design equation. And I will preface by saying that I am a proud member of ASHRAE. Attend every meeting I can. I've spoken at several different ASHRAE meetings as the technical speaker, but there's a problem with the ASHRAE chimney design equation. And that issue is that it is a steady state equation. This is assuming that your stack is primed and heated up and ready to rock. It assumes that your input BTU is continuously the same, which we are no longer selling on-off boilers. We're installing modulating boilers. So that's constantly changing. Well, if that changes, your pressure loss changes, your fluid temperatures change. Everything in this equation is constantly changing, okay? But this is a good starting point. So we use this as a baseline or as a worst case scenario sometimes. We also need to determine pressure loss through the system. It's a whole bunch of letters, numbers, and symbols that tell you what the pressure loss through that system is. Then we also have to determine theoretical draft. Theoretical draft is determined by two things. One, the height of your stack, and then the second is the delta between ambient and fluid temperature. The greater that delta is, the more theoretical natural lift you're going to get. Also, the taller your stack is, the more natural lift you're going to get. Now, there's a caveat. If it's not properly insulated, you can start to lose temperature, which means that lift will start to diminish the higher up you get. But in general, taller stacks have more natural draft. And just to show a quick example, there's a 20-foot building, very short stack. Just by going from a category 1 appliance, typical fluid temperature, down to a category 4 at low pressure, you lose about 0.06 of an inch pressure. Now, that doesn't sound like a lot, but when you're dealing in hundredths of an inch, that's a dramatic drop in pressure. So same thing is true on a on the height of the building, excuse me. If you have a category 1 boiler anywhere in the country, you're going to overdraft that appliance every day of the year. And so for years and years and years with category 1, we've always used mechanical draft devices called barometric dampers. Barometric dampers soak up excess draft. They bring in fresh air, cool the temperatures down a little bit to slow those flue gases. And that works fine on category 1. We don't want to put that on category 2 or 4, mostly because these are made of a powder coated steel, and the condensing can corrode those pretty quickly. So the other thing is we're doing a lot of retrofits. I think 85 to 87% of the HVAC industry is retrofit. It's replacement boilers. It's not new buildings. And so what we're doing a lot is taking out one big 100 horsepower boiler and putting in 3 or 4 modular copper fin or stainless tube condensing boilers. But the owners are wanting to reuse the existing hull. They don't want to poke more holes through the roof. So we put them all into a common vent. And the problem is when you do common venting with high efficiency appliances, you have to size for the full load. Typically, we recommend you size for all boilers on the load. So if you have a N+1 scenario, you should be sizing that vent for all 4 appliances, assuming that three carry the load, 1 is extra. Because then you can, the way that controlling those boilers work and various things. So the problem is that when you have a stack size for the full load and you only put in, say, 15% of that load, you're going to have all kinds of flow issues. So as you can see, the mass flow of that system is constantly changing as you turn boilers on, as the stack gets primed, etc. The other thing is your pressure is all over the map. Again, as boilers turn on and off, that pressure may go all the way from a 0.16 negative all the way up to a 0.13 positive in this scenario. And that's for, uh, like boilers that are just modulating up and down. And so depending on whether the stack's cold, whether you're at full fire, low fire, whatever it may be. So obviously we have to kind of smooth that out a bit. And that's where we come into play with our mechanical draft system. We have 3 different style fans. We have a termination style fan, 2 inline fans. Everything by code must go through an appliance interlock. We can't just put a fan on there and hope for the best. We have to actually monitor the fan, monitor the pressure, and lock out appliances if there's any issues. We do have our UL listings, both 378 and 705, which is required for draft controls. We also use high efficiency motors on all of our products. We've recently upped the EC motors up to 1 horse. So it's a direct drive, direct speed signal from the controller right to the motor. There's no external controllers necessary. And that'll modulate all the way down to 15% capacity. 3-phase motors are high efficiency induction motors. Those are off the shelf Marathon 3-phase motors. High turn down, 10-to-1. We do use an external VFD. And but it's the best news for the end user is that this is a easily sourceable motor. So if anything goes wrong, typically it's going to happen on a Friday afternoon about 4:30. And considering you guys are 2 hours behind my warehouse, you'd have to wait till Monday to get a motor, or you can just go down to your local motor shop, have it rebuilt, or have it replaced and have it up and running that night. This is a typical mechanical draft system. Here we're showing 3 boilers. Having a common stack coming across, we're showing our termination fan. Everything's tied into our interlock controller. You see the wires going to each appliance. There's a transducer that's sensing pressure in the base of the stack there. Basic sequence of operation. Boiler gets a call for heat from its master controller, sends a signal to us, starts our system up. Fan does a fan check. We verify that pressure does change. Yes, the fan is working. We then release the boiler to fire. As soon as we do that, that boiler goes into pre-purge. By code, every appliance has to have a pre-purge to turn over its air chamber 3 to 5 times, depending on the type of product it is. And so by doing that, they pump a whole bunch of ambient air through the chamber and up the stack. Well, obviously, all of that air is going to come up here and be sensed by that sensor. We're going to see a change in pressure. We're going to ramp our fans up. Once pre-purge is complete, fan ramps up, the boiler fan ramps all the way down and goes to ignition. Obviously, when we change volume, temperature, etc., that pressure is going to change. We'll modulate that fan back down accordingly. All we're trying to do is maintain a set point, typically a slight negative, 0.05, 0.06, maybe a 0.10 in this common, depending on the product. And as boilers turn on and off, as boilers ramp up and down, we're going to continue to modulate our fan to maintain that 1/10 of an inch or whatever that set point is, and let the boiler kind of do its thing here in these connectors. Once the entire system is satisfied, we go through a quick post-purge, and then we go back into standby. Our termination fan, our CB, which is being replaced by the CBX, same style, but just a few minor tweaks to it. But it is available up to 19,000 CFM as a sidebar. If you have a 19,000 CFM boiler system, please give us a call. My daughter is graduating from the University of Houston. Would love to get that debt paid off quickly. The fan is rated up to 1,000 degrees continuous. If you have a 1,000-degree boiler system, you have a problem. Boilers today just don't have those types of elevated flue temperatures. However, we do this for 2 reasons. One, we do some industrial projects, kilns, ovens, that type of thing. Secondly, UL 103 is listed for 1,000 degrees. So we went ahead and got our 1,000-degree listing to match the vent system. Again, EC or induction motors, depending on the size. All of our products are available in stainless steel. Most of what we sell is in 316L. It's the type of material that it's an alloy that can handle the corrosiveness of condensate. But if you're in a system where it's a category 1 or it's a steam system, very little chance of condensation, we can drop down to that 430. Our inline fans, we coined the term true line fan construction because they are true inline fans. Our 90-degree fan shares the X and Y plane. The straight through fan shares the X, Y, and Z. So these are a great retrofit application. Many times we get calls where the system was designed to run 60 feet with couple of elbows, and instead the contractor decided to go 120 feet and 6 elbows, which exceeded their the boiler's limitations. And so we had to go in after the fact, brand new project, and install have fans installed in the system. So what they'll do is they'll take out a piece of pipe, or they'll take out a 90-degree or a boot tee, plug these fans right in, and away we go. You don't have to hang anything else, rehang any pipe downstream from it. And that is why the TRV looks a little bit a little cattywampus here on the fan housing. It's to make sure we can get our inlet and outlets um, to match up along with the velocities of the fan, maintain certain velocity through the fan. So up to 9,000 CFM. These are approved for outdoor installation. I have 2 of these on a rooftop in Denver that I visited my first month working here in 2015, and they've been working great. So still rocking to this day. Our 90-degree fan goes up to 16,000. Again, can be installed outside. One thing you might notice, and I'm not sure if you can see it through the screen here or not, but all of our inline products have a drain plugs, have drains welded from the factory. You don't have to modify the fan in any way, shape, or form to install drains. Again, condensate's very corrosive. It will eat through anything. Stainless steel, concrete, anything you put in its path, if it sits long enough, it will corrode that material away. So we want to get that condensate out to a neutralizer and then get it to drain as quickly as possible. So we provide drains on all of our inline products. So that takes care of not having enough draft, but what happens if we have too much draft, right? We start getting down into this range here, we start having too much draft through the system. Well, we have what's called our overdraft control system, where we put an inline damper in the system. And if if this system needs draft, the fan will ramp up. If it's starting to get too much natural lift, it'll bring the fan down to its lowest speed, and then it'll start to choke off with the damper. Many times we'll use this damper also as a trim damper for the fan. My fan has a 10-to-1 turn down. If you have 6 boilers with a 10-to-1 turn down, your system is now a 60-to-1 turn down. My fan just can't drop low enough to maintain the pressures that are needed. So it will mechanically overdraft the system. So we start to choke that off with our damper. Best part is it works with single controller, so that it's not trying to fight each other at all times. Our OBD is a multi-blade opposed blade damper, fast action actuator. We actually worked with a manufacturer on this. It's the fastest one in the market to my knowledge. It's 2 seconds full open to full close, and vice versa. The high temp models actually have recently passed up to 1,000 degrees, so this can be used on those UL 103 applications. We can provide end switches to prove open and close on. We have a lot of on-off applications as well with these. We say we offer them in 304. I can count on one hand the number of 304 dampers we've sold. One thing I'll point out, all of our inline products have a raw collar. That way we can work with Austin and his team to determine the type of products that they're using, and either come up with the proper adapters, or we can use flange adapters to to make sure that it's a completely UL listed system. So I just saw something pop up in the chat. It says all the inline fans, all components are fully stainless steel. Yes. So whatever the housing is, the impeller and our motor shafts are all stainless steel. So yes, I apologize if I overspoke that, but yes. So all of our inline products, actually all of our products are available in 316L stainless fan, housing, impeller, etc. So hopefully that answers your question. If not, feel free to continue on in the chat. So we've talked about fans and dampers. We do things a little bit differently than some people, but where we feel like we've really pushed the envelope in this industry is in our controls. So typical systems out there, and as a sidebar, I've been selling, involved in draft controls since the late 90s. And this is the controls that were always the ones that were kind of the default, right? But they run from 0 to 0.6 negative. And with a set point of an 04, 06, 10, it doesn't give you a lot of room on the top here. So what happens is fan gets a call for heat, or appliance gets a call for heat, and fan starts to ramp up, and that appliance starts to starts its pre-purge. So there's a big spike in pressure. Okay. The problem is that that fan controller only sees it being 400ths away from set point. Um, well, that's a problem because it only sees that slight difference. So now it's going to slowly ramp that fan, but that pressure continues to rise, all the way up to a half an inch possibly. Now, eventually, it gets to set point, and gets back to gets the pressure back down to where it's supposed to be. However, with us, we actually read plus or minus 1 inch. So we see that spike, we react to it very quickly, typically 50 to 60% faster, and we get it to set point. Now, full disclosure, if this is a single appliance, this would work just fine because this is going to happen during that pre-purge moment. However, if you have multiple boilers and one boiler is operating and we're at our set point of 0.04, 0.05, as soon as that second boiler gets a call for heat, it's going to bump a whole bunch of cold air into that system. That changes volume, changes temperature, changes pressure. There's going to be a huge spike. And what happens is it actually creates this blockage because the fan doesn't ramp up fast enough. It'll create this system going positive. This fan overcomes this fan and starts to push flue gases back into the operable boiler or toward the operable boiler, creating a blockage. That boiler then goes off on a block flue switch because it sees that positive pressure. However, the fan ramps up fast enough so that this boiler can light. And then it gets to set point. The master controller says, wait a minute, I've lost a boiler. We still need a second boiler. Tries to turn on the third boiler. And it does the exact same thing. Especially in a setting, I've pretty familiar with some of the products that DB Sales has sold on the boiler side. So I know one of their manufacturers, their control sequence will ramp the boiler up to about 60%, and then we'll turn on a second boiler. So you're not getting 100% of CFM versus 100% CFM. It's 60% of CFM versus that 100% during pre-purge. So you'll actually overpower the running boiler. So you just have this system where it's just cycling over and over and over on a block flue switch, because block flue could be an automatic reset. So you'll have a lot of cycles, but you won't have a lot of run hours. And that's how you can tell that you have a venting issue, is if you're constantly short cycling the boiler. It's either that or a temperature swing issue. But point being is, in that scenario, the only way that you can overcome that is to oversize this stack. So you have more volume, which means that that change is affected less, or put in a control system that can handle plus or minus 1 inch, which is what we do. And again, if your set point's here, you don't have a lot of range. To me, the analogy I use all the time is, if you had a 100-degree system, you wouldn't put a 105-degree thermometer on it. You'd put a 0 to 200, 50 to 150, whatever it may be, so that your target is close to the middle of that temperature gauge's range. And that's pretty much what we're doing here. A typical setting is going to be in this here. So now we have room on either side of set point to make the changes necessary. And that's true of all of our V-Series controllers, starting with the baby one at 150 all the way up to the 350. They all have that EC flow technology, true bi-directional, positive and negative at the same time. There are some manufacturers that are coming out saying that they are also bi-directional, but what they've done is they've taken that 0 to 6/10 and they've just flipped it. So now they can read positive or negative. We can read across 0 with all of our controllers. The other thing that allows us to do is it gives us a high and low pressure system. If you're reading negative pressure and you don't have a high pressure alarm, that is your first point that you'll know that there's something wrong with your fan. If you don't have a high pressure alarm and your fan dies, you have to wait for that pressure to build up in the boiler itself and have that block flue switch pop. So we'll actually see that at our sensor where, hey, we're outside of our range. We need to go into alarm and lock the boilers up. Everything's field programmable. So we do have defaults built into the controller, but every system is different depending on sensor location, the number of elbows, the distance between the fan and the last boiler. All of that affects how the system's going to react. So that's all adjustable, all of our PIDs. I would say 85% of the time the defaults work. All you have to do is adjust your set point and your alarms, and you're good to go. It does have an integrated disconnect switch for service. We have 3 different options for interfaces. We have a simple 4-button LCD control. Works great for a simplistic system, but we also offer a 4-inch or a 7-inch color touchscreen in in some of our larger models. And then Modbus is standard. First question I always get, can we get BACnet? Yes, we can do that through a gateway. There's just a quick screenshot of the our 300 series controllers. Um, Everything that you need while you're tuning the boiler is on that screen. So it's really simple for commissioning. Just come in here, set your high limit, your low limit, your set point. The nice thing is that this is all happening in real time, so you can see how those changes are affected in the system. So we've talked about designing around maybe boiler limitations, venting. And that's typically where we'll get the call is you're common venting, 3 or 4 boilers, and the manufacturer says you can't do that naturally. So we'll get called in on that. Or we've exceeded the boiler's length on how far you can run a boiler, and we'll kind of get called in on that. But sometimes we get called in for code violations that the boiler can handle it, the venting system's within range, but we have certain code violations. So one of those is, I call it the 10-foot, 3-foot rule. Basically, anything within 10 feet of your termination must exceed that by 2 to 3 feet, the height of that by 2 to 3 feet, depending on what it is. Parapet roofs, pitched roofs, cooling towers, anything that's in the way of that vent, you have to extend your vent 2 to 3 feet beyond that. That's why I call it 10-foot, 3-foot. Very simple to remember. Many times people ignore that and just do stuff like this. This is very common, just putting a cap on a curb. That is not a 3-foot curb, so that does not qualify. We call this the Texas Special. So we have a lot of 3-story apartment buildings with single-story mechanical rooms. They replace the roof, and then they want to they want to put water heaters in there. So they put category 1 tank type water heaters, and they blow them out the sidewall with B-vent. B-vent is not a category 1. You cannot go sidewall with category 1. So we informed the contractor of that. So they decided to put a 90 and a piece of pipe with a cap. That still doesn't qualify because you have to exceed that parapet roof by 3 feet, but then you've exceeded the amount of exterior B-vent, et cetera, et cetera. So a lot of issues there. We could fix that with a couple of cap fans right on the sidewall there. This one, they tried to clear the parapet wall in the back, but they forgot about this building right here. So that's a problem. And then this one I can't fix. That's just, yes, that is a makeup air unit intake hood. And yes, that is an exhaust pipe. Needless to say, that was not allowed. So,
Hey, Jason, real quick
yep.
before you move on, I have Eric Polito asking where the 2/3 rule comes from, which particular code?
Sure. I believe this is NFPA 54, Chapter 12. So it stems from Category 1 appliances, but it actually holds true for all. If you read later in the code, it does extend into that as well.
Okay, thank you.
No worries. So the way we get around it, because we are a mechanical draft system, we are considered an engineered system. You'll see in NFPA a lot of times it'll say you have to do this, or be an engineered system. And so we fall under the engineered system category. And so what we can do is actually lower those terminations because now we're mechanically pushing through what could be that blockage. And the reason that exists is you could get a wind that hits that sidewall, and just the vortex of that wind can actually create back pressure on your stack. So you actually have to extend it above that. This was actually a project we did locally here in the Dallas area. It was a brand new hospital, medical center. And there were 2 steam boilers down in the basement, up through 2 stories, up through the roof. Everything worked great. And then about 6 weeks after the project was commissioned and the building opened, they couldn't get either boiler to light, and they didn't know why. So rep went out there, and come to find out, they had decided that the director of the building didn't like looking at 2 stacks coming out from behind his sign. So he had them go up there and remove those stacks. And so they were down to here. And again, they were getting this crosswind and creating too much back pressure on that boiler. So put the piece of pipe back on, lit right off, no problems. So then they said, well, you can't leave it like this. So we said, well, for aesthetic purposes, we can put a fan and bury it behind that wall. So now they can't see it from ground level. And it sounds really kind of silly, but if you ever go to um, Disneyland or Universal or any of those, places where their entire business model is based on aesthetics, um, you have to hide as much of that stuff as you can while still meeting code, and that's why a lot of mechanical fans are being, used in those applications. 7 times area rule. This means your largest, the area of the largest vent cannot exceed the area of the smallest vent by 7 times. Um, basically, that means you can't put a 4-inch vent into a 32-inch chimney. Again, this comes from category one. But a lot of times we'll see this in school districts where they had an old big fire tube boiler that was doing everything, steam and indirect hot water and kitchen. And well, they've abandoned the kitchen and they've broken off the water heaters, put those in a corner for a little hand sink or something. And then they're replacing it with condensing boilers. Those are going sidewall, but they still have this 40-gallon water heater dumping into this brick chimney. Um, and that's a no-no. So way you get around that, put a fan on it. Again, we're mechanically inducing that draft. The other way is you cannot combine category appliances into a single stack. So you cannot put a category 1 water heater in with a category 4 boiler or a category 4 boiler with a steam boiler. You can't do that naturally. However, if you use a mechanical draft system, you can combine products. We actually had a project in Chicago. They had 4 water heaters, 3 humidifiers, and 4 boilers, all going into a common stack. 1 fan, and there's some things we had to do, which we'll talk about here in a minute. Good venting practices. If you're doing mechanical draft system, we highly, highly encourage a common header all the way across past that last boiler with a T-cap. Reason why is that my sensor is best used right here. That way I'm in a spot that's not affected by velocity. It's just affected by pressure. So I can get a true sense of what the pressure across this header is going to be. If I had it here or here, that pressure is going to change. Imagine a garden hose. If you kink it a little bit, the volume and the pressure and on one side of the kink is going to be different than the other side of that kink. So we always ask for a common header all the way across. The other thing is, if you learn nothing else today, lateral tees are your friend. Okay, flue gases are really stupid. They do exactly what you tell them to do. So if you tell them to bang their head against this wall, it's exactly what they're going to do. Creates a blockage, okay, becomes a turbulence issue. Okay, boot tees and lateral tees are not the same thing. Boot tees are better than straight tees, but they're not a lateral tee. A lateral tee is like merging onto the freeway versus stopping in a turn lane on a stoplight versus a four-way stop. Okay, that's your automobile analogy. You can pretty much get on the ramp and get up to speed as you're getting into traffic with a lateral tee. Here, you have to come to the stop and yield to traffic, and it just kind of opens and you hope for the best. This is just a bad idea. Okay. Now, if you don't have the space or if cost is an issue, yes, lateral tees are the most expensive option, but it's the right way to do it. So it gives you the best flow, just makes everything kind of work that much better. So, all right. So overdraft. So we've talked about everything we've talked about so far has been the pressure. We control the pressure in this common, right? We're going to have a sensor here. Here's a better diagram. We're going to have a sensor here with an inline damper, an inline fan, and we're going to maintain a certain pressure in this system, and it works very well. We can keep boilers within their range, and everything's great. But it would be better if we could actually keep the pressure exactly what the boiler wants at the outlet. And so what we've done is we've created what we call our CDS. The CDS is the connector draft system is an individual draft controller for each appliance. So now we're going to have our own damper, its own controller, its own sensor, and it's going to monitor pressure right here in this connector. As that boiler is operating, modulating up and down, that damper is going to modulate to make sure that the outlet pressure is always whatever your set point is. And this boiler does not affect this boiler or this boiler. Now, sometimes we'll do the common header naturally. Sometimes we'll have a fan on it. It'll depend on the application, depend on the boilers. this is also great for, again, I talked about that job in Chicago where we had 10 different appliances, 3 different styles. Each of those appliances had a different pressure requirement. The boilers wanted to be slightly negative. They were more of a category 2. They ran really well at about a 0.04, 0.05 negative pressure. The humidifiers ran fantastic at neutral. They wanted to maintain 0. The boilers, they wanted to be a half an inch of positive. And so what I was able to do was put a fan, ran that fan at a deep negative to make sure we exceeded the deepest negative needed, right? Made sure everything stayed negative in the common. But then the boiler damper said, no, we're going to choke that down to about it, to maintain that back pressure, create back pressure at the boiler, which is what the boiler was commissioned to, which means it always had perfect draft. It always had the best scenario for combustion in that appliance. And so it assists with light off. It assists with um, maintenance. It assists with, again, always maintaining that perfect draft. And again, when I first started this, we talked that venting was 90% of your problem. So if I eliminate all of those problems, my venting is always consistently going to be whatever you want it to be at the outlet of the boiler. I've just eliminated 90% of your boiler problems. Okay. We introduced this in summer, fall of 2017, and it has quickly become our number one selling feature, selling product in the country. And we have some manufacturers, some of our reps, they're putting it on every boiler, especially up in the colder climates, remote areas where they don't want to get a call saying that we had a nuisance flame fail because of a crosswind or something's just not right. So they just put CDS on everything. It is a single blade damper of all 316L. Fast actioning actuator. We talked about the 2-second actuator. Our system dampers really don't need that type of an actuator. These dampers absolutely do. So we're very quick reacting. It does have a Viton seal for positive shutoff. Available for, I just saw the question come in, 4-inch up to 16-inch with our single blade dampers. And then we do have feedback signal. Again, Modbus on board, so we can send all of that information to the BMS to tell you exactly what the boiler is doing, or the boiler venting is doing at all times. So again, this has really allowed mechanical draft and mechanical venting to go to a whole nother level. And the analogy I always use is it's like going from a full flow piping system to primary, secondary. Now I am going to maintain exactly the amount of the type of draft I need at each appliance. And I really don't care what's going on up here, so long as it allows me to maintain those pressures. Okay. So it's a great product, and it's we've did a project. I don't want to, has to do with defense contractors, so I don't want to discuss too much. But we did a project there in just outside of LAX, and again we had 4 RBIs and a steam boiler, and so now they're set up to run. The 4 boilers are set up to run one way, steam boiler set up to run another way, and then the fan just evacuates everything. So yeah, so that's our connector drafts. Combustion air, the final piece of the puzzle is, how do you get air into the space? There's a few different ways. You can obviously put big louvers in the wall, or you can put pipes going to the boiler. We have offered what we call our pressure air system. So instead of having a big louver in the wall, or instead of having a big duct running to drop down to each boiler, we'll just have a single pipe, dump it into the space. We'll have an inline fan, controller, outdoor sensor, pressure sensor in the room. And all we're going to do is modulate that fan to maintain neutral in the space. As boilers come on, they pull air from the space. My fan ramps up. My pressure sensor sees that drop in pressure, or ramps the fan back up to get it to neutral. We can tie in to the inlet, just do a header across and drop off to each boiler. There's a little bit of trick to programming the controllers for that, but it can be done. The other great thing is, if you're already doing a draft control system for your exhaust, we can use the same controller. All we have to do is add a fan, room sensor, outdoor sensor, and you have a combustion air system. So it's a very cost competitive option now when doing combustion air and venting together. Finally, boiler room safety. So this is something we have been spearheading across the country, and that's carbon monoxide detection. state of Texas recently implemented to where every mechanical room requires a CO monitor that interlocks with the appliances. And if you know anything about Texas and California boiler codes, they like to kind of piggyback off of each other. As soon as one does something, the other one does it, tries to beat it. Very competitive in that regard. So I would not be surprised if California does not require it here in the coming years. It might even become a national code. I know NFPA has talked about it, but point being is this device is designed to specifically interlock with mechanical appliances. We have a two-stage system. We have two relays basically, so it can either run as a single appliance two-stage system or two appliance single-stage system. We can also extend it with an expansion board up to 15 appliances, or you can use it in conjunction with a master gas valve. Tie it in series with your punch switch on the wall if you have an emergency shut-off switch. Tie it in series with that, and it will shut everything down in the space. And basically, what happens is, as the CO climbs in the space, it's a two-stage system. So stage one is set for 50 ppm from the factory. If it gets to that stage, it starts a timer. That timer is adjustable from 2 to 5 minutes. If it stays above that level for that time period, it shuts off the appliances, manual reset. If it gets to stage 2, which is factory set at 100 ppm, it immediately shuts the appliances off. Again, manual reset. And again, it ties into the alarm circuit of the boiler. It does not go through a BMS, does not go through some secondary thing, because that is something that can be bypassed with a simple jumper. We recommend tying this in again directly to the auxiliary limit circuits of the appliances. If you're doing a draft control system, we're going to tie this into our draft controls, because our draft control, our interlock controller, is tied into the auxiliary limit system. So by proxy, we are tied directly to the auxiliary limits. Again, it's required in the state of Texas on all boilers, starting this past January. Prior to that, it was just direct vent. They said, that's it, we're done. Just put it on all boilers. State of Maryland requires it in anything, all commercial buildings. Massachusetts requires it in all their schools. Yeah, like I said, one by one. Georgia just passed all mechanical rooms require a CO monitor, so it's coming. It would not surprise me if it's not a federal code here in the coming years. So put it on all your boilers. Mine or someone else's, doesn't matter. Biggest pushback I get is from the BMS guy. Says, "Oh, I got a CO monitor sensor, and we'll shut it off through the BMS." It takes nothing, and Austin could attest to this. If you lose comm to your boilers, the boiler says, "Hey, I've lost communication. Let me just go into local mode," and it turns on its own, based on its own thermostat. So you've basically bypassed that safety device. So always recommend it go directly into the auxiliary limits. Sizing calculation. So everything we do comes with a sizing calculation report. We'll tell you how we came to what we did, or why we did what we did. Gives you velocities, CFM, static pressure through the system, and that way you can put that in your files for reference in the future. That pretty much wraps it up. I've put the contact number for Austin and his team. That's their main number, along with their general information. And I know Austin and Trace will probably send out some more information post here. But if you have any questions, I've got a few minutes to stick around. We can do that through the Q&A button and go from there. But other than that, I will pass it back to Austin.
All right. Thank you very much, Jason. Thank you very much. Yeah, so just like Jason said, if you do have any questions, we'll be sticking around here for a little bit, answering kind of questions you have. If not, feel free to reach out to myself or my team in the areas that we cover. That would be LA, Orange County, San Diego for the most part. But again, thank you very much for attending, and I will leave the floor open to any questions. Thank you very much.
Jason, it looks like there is one question of what are the sizes of the CDS2?
Yeah, sure. So the CDS2 is 4-inch up to 16-inch diameter. That would be with our single wall. We can, I don't want to say Frankenstein, but we can do one with our multi-blade damper. Anything over 16 inches, single blade damper just doesn't have the torque. So we use our multi-blade damper going up to that. So, yeah. So 4 to 16 inches, the prepackaged unit that I showed you right here.
There we go. Yeah, and then we have a question from Caesar Cruz about the carbon monoxide sensor. Would it be required in existing buildings?
That's up to your local jurisdictions. Right now, state of Texas does not does grandfather in old systems, but anything new or repair work would have to be replaced. However, some of the local inspectors are taking, so in state of Texas, you have to get inspected yearly by either your insurance company or the state. And if you get inspected and have to do anything, including a PM, that means you're modifying the boiler room. Therefore, you have to put a new sensor in. So that's kind of a backdoor way of requiring them on grandfathered systems. So again, but that's just Texas. I don't know what California and LA are doing there. So my guess, if it becomes a national thing, it would be a grandfather new or repair work only.
Yeah. Then we have another another question from Eric Polito. It's seeing if you could show the combustion air fan diagram again.
Sure. Yeah. So this is just a generic conceptual thing. Obviously, this pipe would go through the wall. The controller and the sensor here would be in the room. This would be an outdoor sensor. So we're basically just trying to match the atmosphere, so that the room always has atmospheric conditions to pull from. But there's several variations, Eric, that we can show you with specific, if you have a specific job. And this is just using a box fan. We have a 90-degree fan. We have we're actually working on a new tube axial fan that'll be a much more cost-effective option than that as well. So, and then I'm looking at the Q&A. Oh, Austin's jumping on that. So, do we have products that combine intake and exhaust in the same pipe? So we do not deal with vent piping. I don't know if Austin and his team, typically concentric flues are appliance specific. If you're not approved for a concentric vent as the manufacturer, you can't just do that as a field thing. So typically those are limited to residential, light commercial, maybe some wall hung things. But I don't know, Austin, if you know of anything that you guys offer. I don't want to steal your thunder on the sales side of your products, but I'm sure there's a few things that you guys sell that you can use concentric venting with.
Yeah, we do have some products that we do concentric venting with. Not all of our products do that, but a couple different brands of our water heaters do that, and then of course some of our boiler lines do that as well. Yeah. So we do have products that do.
But those are typically smaller capacity. Yes. I mean, you're not going to get into your 2, 3, 4 million.
No, exactly. No, smaller capacity, definitely. If there's anything in particular that you were thinking of, feel free to reach out either to me or to one of the sales team. We can answer your questions a little bit more in depth.
Perfect. And then I saw Doug. We've got him going back and forth. So I don't know if you want to. There's the main phone number, Doug. Otherwise, Austin, I don't know if you want to put your email out there for the whole internet to have.
Yes, absolutely. Doug, I answered your question. I sent you a little message. I'll forward my contact information to you, and we can get out there to take a look at the site you have. If there's particular questions or some project you're looking at doing, incorporating a draft system with. So I'll forward my contact information over to you.
Cool. And then I see Amir has his hand up. I'm not sure if Amir, if you had a question or if you want to jump on mic and ask, or if you can just type it in the chat window, we can answer it that way as well. But
no, Amir has. I don't know. Let's see.
May have been an inadvertent button too. So
might be, yeah.
Yeah. So
all right.
Cool. Well, yeah, I think, like I said, I can stick around for a few more minutes, but other than that, I think pretty much wraps it up. Austin, I'll let you kind of wrap it up and go from there. Again, thank you guys all for attending. Hope everyone's staying safe out there. And if you have anything, get with Austin and his team, and we will work with them to design the system for you. So thanks again.
Thank you very much, Jason.